Hi, I'm Tom Beebekauser with Wetland Restoration and Training. I see the ghosts of drained wetlands wherever I go. Right where I'm standing, I can look at my feet and the small pipe shows me that large areas of wetlands were drained on this farm. The larger pipe shows me that streams were moved to drain even greater sized wetlands. In this video, we're going to be looking at the history of wetland drainage. We're going to be looking at the techniques that people have developed over the last couple hundred years for draining wetlands. And I'm anxious to show you that you can recognize these practices and take action to restore these wetlands. Let's get started.
This photograph shows a dredge draining a massive wetland in the year 1888. The wetland was named the Inlet Swamp and was located in Lee County, Illinois. I have been studying how wetlands have been drained and filled for over 50 years. What I'm about to show you will both shock and dismay you. The natural landscape was very different in 1804 when Lewis and Clark began their epic journey from the Missouri River to the Pacific Ocean. There was an abundance of wetlands on the landscape. The sight of bulrushes and muskrat houses was commonplace. There were cattails growing along the water's edge. Huge flocks of ducks filled the sky as Lewis and Clark approached the wetlands. The sound of thousands of geese taking flight was deafening. The swamps were so large they took days to cross. Beaver were everywhere, and the many dams beaver built flooded the valleys. Looking down from high ground 200 years ago, one could see beaver ponds like pearls connected by strings of wetlands. Streams were as sinuous as giant snakes, and the water in streams readily overflowed their banks when it rained. River floodplains were largely wetlands containing thousands of oxbow-shaped marshes. This aerial photo taken in 1929 shows the amazing abundance of wetlands of different types on the floodplain of the Kootenai River in British Columbia. Indigenous people were using willows and the roots of sedges to make baskets like this one. The worms used for fishing were carried in containers made from bulrushes that were also growing in wetlands. The Seminole made shoes by weaving cattails. The Ojibwe harvested bulrushes and wove them into floor mats. This teepee was made by the Lower Kootenai using bulrushes from wetlands. The natural landscape was soon changed by the western expansion of Europeans who cleared the forest and plowed the land to grow crops. The passage of the Homestead Act in 1862 by President Lincoln accelerated western expansion by granting 160 acres of public land to adult citizens, including women, freed slaves, and immigrants who paid a small fee, lived on the land for 5 years, and cultivated it. The act aimed to promote agricultural development and provided 270 million acres to settlers over its lifetime. Early settlers were interested in growing corn on the land that they cleared. They worked tirelessly to plow the fields and to plant their crops. Unfortunately, the upland areas they plowed were quick to erode. This hillside has so many gullies it can no longer be farmed. One heavy rain has ruined this field that was created on a slope. Farmers had little success trying to grow crops in the bottomland we call wetlands. This horse is unable to pull the cart out of the wetland without the farmer having to unload it and then reload its contents. Trying to farm a wetland was a real problem because horses and mules would get stuck in the mud and the planted corn and the wheat would drown. It was most inconvenient getting your buggy stuck in a farmed wetland. People had to figure out how to turn wetlands into productive farm fields so they could feed workers in logging camps and at mine sites. Refrigeration trucks were not invented, so you needed to grow food near where the people were working. Here's one of the earliest low-tech process-based techniques developed for growing crops in wetland. The wetland basin is reshaped to form parallel raised ridges we call lands. The areas where soil was removed to make the lands was reshaped to form what is called a dead furrow. Here John Newman is standing on the crest of a land his grandfather made using mules and a plow near Fox Creek in Fleming County, Kentucky. It takes much work to maintain a field inlands because the trees and shrubs that grow in the dead furrows must be removed, often by hand. The trees and shrubs will shade the crops if they are not controlled. The wetland on the left is being farmed in lands. The wetland on the right has not been drained. This tobacco field, located in Carter County, Kentucky, is being farmed in lands. It's easy to see the raised lands and the dead furrows that are like ditches that don't drain. This is how the lands technique of farming a wetland is supposed to work. The tobacco plants growing on the lands are tall and healthy. Here you can see the tobacco plants growing on the sides of a land and near the dead furrow. This crop is stressed because of too much moisture in the soil. Notice how the farmer is keeping the grass mowed in the dead furrows? This is often done by hand using a string trimmer because the ground can be too wet to use a mower with rubber tires. This wetland was farmed in lands years ago. The shallow dead furrows are dark in color because they contain standing water. The land's pattern of draining and filling wetlands is clearly visible on this aerial photograph. The main way of draining a wetland is to dig a ditch. Digging a ditch is very hard work. These men are digging a ditch to drain a coastal marsh. The job is hot, dirty, and miserable, and you're always getting stuck in the mud. Here I'm digging a ditch to keep water from flooding our barn. Our barn was built on a filled wetland. When you see a ditch, you know somebody has drained a wetland. The soil removed from digging this ditch was shaped to form the road. This ditch was hand-dug by slaves owned by the Dismal Swamp Land Company in the 1700s, of which the first president of the United States, George Washington, was a partner. Let's look at how ditches are used to drain wetlands. First, every wetland is formed in a basin. The basin is surrounded by a rim that acts like a natural dam to keep water in the basin. A wetland is drained by digging a ditch that cuts through the natural rim of the basin. This drawing from a 1973 Soil Conservation Service book shows how a ditch drains standing water and will lower the elevation of groundwater in the soil. The same government publication shows how ditches are dug down the center of a valley to drain wetlands and along the base of the hill to divert runoff from entering wetlands. It is difficult to find a photo of somebody digging a ditch. This is because they often want you to help dig the ditch instead of standing there taking photos with a camera. In the short video you're about to see, the late Merlin Spencer is explaining how his grandfather moved Beaver Creek in Menifee County, Kentucky, so wetlands could be farmed. We miss hearing him say in the first part of the video that his grandfather first dug a shallow ditch along the base of the mountain and then blocked the stream so it had to flow in the ditch when it rained.
Well, it'd make that channel a little bit bigger and a little bit deeper. Well, then it got to reaching out over the bottom still, and it got to dropping the sediment. And then first thing you know, we had a big channel cut. So that's the way they straighten the creek. And there is another place that I never did tell you about on the upper end of our property. And if you go over, it grew up in walnut trees. But it's really obvious where the creek used to be. And I can remember in my lifetime wondering why the old big sycamore was like this with a hole under it, not realizing that he had straightened it again up there.
The natural Beaver Creek was shallow with low banks. When he was a boy, Merlin could jump across the stream. Here Merlin is having me show how water in the unmoved Beaver Creek would flow across the field when it rained. Here's the moved channel of Beaver Creek that is still eroding. The moved Beaver Creek continues to cut deeper and wider. People have been trying to dig ditches with greater efficiency for many years. High nitroglycerin dynamite was used to dig this ditch to drain a wetland in Minnesota in the year 1928. This deep and wide ditch was dug using dynamite over 70 years ago to drain wetlands at Cherry Meadows in British Columbia, Canada. Here, ditching dynamite is being used to remove the soil that has filled ditches on a farm in New York State in the early 1900s. These individuals are using what is called a mule scoop to dig ditches and to fill wetland basins. Here, Merlin Spencer is showing us how to use a mule scoop so it will dig and not throw us over the top when moving soil to drain a wetland.
How did you hook this up? What type of hitch and
And how was it held?
This type ditch with a couple horses.
A couple horses, and what angle? Only what
Very
angle?
flat. Just carry it like that until you want to load it and raise it up, just like you've got
And
it.
raise it up, and I bet
It'll
it'd
go
bite
down.
pretty good, wouldn't
And
it?
if you lift it too much, it'll flop over and dump itself right there. And then when you get there,
So you're holding it down like this. You're getting
Yeah.
it down low
yeah,
on this.
and it's scooping up real ever so slightly. And then when you get to the other end and you've got it full, well, when you get it full, just push it down. Let the team drag it. You don't have to hold it no more once you get it full.
Right.
The weight back here will kind of keep it nosed up. And then when you get to the other end, just like a wheelbar, just flip it over. And the horses drag it back upside down.
These individuals are using a wooden V-plow with a metal cutting edge to dig a ditch for draining a wetland. This is an advanced operation requiring 4 mules and 3 people to guide the animals and the V-plow to ensure the ditch is dug at the correct grade and elevation. This photograph shows Stillwater Creek in Wolfe County, Kentucky, after it was relocated into a deep, wide drainage ditch in the center of the valley. Local landowners taxed themselves to raise the funds needed to hire an engineer who designed and oversaw construction of the ditch. Their investment reflects how important draining wetlands was to them to create farmland. Despite their limited means, most did not own tractors. The community came together to transform the landscape. The haystacks visible in the field, which were made entirely by hand, provide a clear indication of the labor-intensive farming practices of the time. Many wetlands were drained by digging shallow ditches along the base of a hill or mountain, and this was done to divert runoff from smaller streams so it wouldn't enter the wetlands. The red dashed line shows a diversion ditch that was dug to drain a wetland. The ditch and the soil pile were carefully designed and built so they would not erode and could still be farmed. The Natural Resources Conservation Service designed and helped finance the construction of many of these diversion ditches. The blue dashed line shows where a stream was moved to dry fields for farming. The ditch was placed on a gradual slope with wide sloping banks so it would not erode. An Army surplus dragline from the Korean War is being used to dig a diversion ditch along the base of a hill on the James H. Hall Farm in Powell County, Kentucky. You can see groundwater entering the bottom of the ditch as it's being dug. The red arrows point to soil piled along the other side of the valley where a second ditch was dug to move Hatton Creek so it would not flow over the farm field. Deweese Cofer is standing next to a diversion ditch that was dug to drain wetlands on a farm in Bath County, Kentucky. This is Slab Camp Creek on the Danube National Forest in Kentucky. The stream is a ditch that was dug along the base of the hill to dry wetlands for farming. The ditch has eroded down to bedrock. The stream lacked pools and riffles and went dry every summer. This is a LiDAR image that was taken on the Sumter National Forest in South Carolina. Red arrows point to diversion ditches that were dug by hand in the early 1800s to dry wetlands to create fields for growing cotton. Ditches have their problems. Most ditches require maintenance. This ditch is partially filled with soil and is too soft to cross with a tractor without getting stuck. A major problem with using ditches to drain wetlands is that the ditch separates one large field into 2 smaller fields. It is expensive to install a large culvert or to make a bridge so you may cross a ditch with a tractor. The red line shows where a ditch separated a large field into 2 fields. Another problem is that beaver can block ditches and flood your fields. Farmers learned years ago that they could dig a ditch to drain a wetland and then build a structure out of wood and place it in the bottom of the ditch, covering the structure with soil. They could then farm over the top of the ditch with a buried wood structure, continuing to remove standing water and lowering the elevation of groundwater so the roots of planted crops could grow deep into the ground. This wetland was drained years ago by digging a ditch down the center of the valley. The farmer then dug numerous ditches through the wetland that carried water into the deep ditch. The farmer split western red cedar logs and built log A-frame shaped boxes that were buried in the bottom of the side ditches. The wooden structures are still keeping the field dry enough to farm. Edward Downing uncovered this buried three-sided drainage structure made from wooden slabs in the early 1960s on his land in New York. The condition of the wood was excellent, and the drain was believed to have been constructed in the mid-1800s. John Newman was helping his father install a plastic drain line in their 5-acre bottomland field near Fox Creek in Fleming County, Kentucky in the late 1960s when the backhoe operator uncovered a wooden drainage structure. The box was three-sided with an open bottom. It was made of boards that had been hand-sawn and hewn from chestnut, with sides measuring 2 inches thick by 6 inches wide, with a rounded top covering the sides. They found it buried at the same depth that they were digging to place a new drain line, which was about 30 inches deep. The box was open and carrying water, said John. You could reach your arm back in it and feel that it was clean inside. John's father, Ronnie Mitchell Newman, who was born on the farm in 1899, said that the farm's previous owners, the Campbells, must have installed the wooden ditch before they bought the farm. This beautiful field is found in the late Merlin Spencer's farm in Menifee County, Kentucky. The field was once wetland. Merlin's grandfather drained the land by hand-digging ditches and then building three-sided boxes made from chestnut slab wood and burying these boxes in the bottom of the ditches. One of the boxes he built and buried was over 500 feet long. Merlin's son reports that the wooden boxes are still draining water from the field over 100 years after his great-grandfather had installed them. One can tell the field on the Spencer farm used to be wetland by the presence of the old pin oak tree that once grew in the swamp. The base of the tree is buttressed, showing it grew in wet soil. The presence of the old pin oak tree, large dry basin with clay-textured soil, and the stream that was moved to the base of the mountain shows this field was made by draining wetland. Here landowner Merlin Spencer is showing a wetland restoration class the outlet for the wooden drainage structure. The old drainage books that I collect describe how small diameter trees or poles can be buried in a ditch to drain a wetland. Henry French, a drainage engineer, illustrated how wood pole drains were being used to dry wet ground for farming. While restoring 72 acres of wetlands and streams along the Dix River, we uncovered 4 buried drainage structures that were made from tree trunks that were buried 8 feet deep in the ground. These log drains were fully functioning and carrying large quantities of water, even in a drought. Contractor Ferris Osborne points to one of the buried log ditches that we uncovered while digging the trench for a groundwater dam. Here's a close-up showing some of the many logs that were buried 8 feet underground. The log drains ran the entire length of the field. The logs were perfectly preserved, and water was still flowing underground in the spaces between the logs. The logs were well preserved and were carrying a steady stream of water. Wetlands were drained to create this farm field by burying wooden poles to carry water underground into the moved and channeled Bear Creek. The wood poles were stacked in piles of 6, with poles averaging 4 inches in diameter and 16 feet long. Miranda Cross is standing in an agricultural field that was made on Cortez Island by cutting western red cedar trees, digging ditches, and then placing logs in the ditches. You're looking at a buried drainage structure made from western red cedar logs that were buried 1 meter deep in the ground. The drainage structure was still functioning when we restored a wetland on the site. Farmers have known from Roman times that the way to drain a wetland is to dig a ditch and then place rocks in the bottom of the ditch and then fill the ditch with soil. You can farm over the top of the ditch, and the ditch will continue to remove standing water and lower the elevation of groundwater in the field. This agricultural field on Salt Spring Island in British Columbia was made by draining wetlands with rock ditches. No open ditches were present, and only small patches of sedges were growing in the field. We uncovered this functioning rock drain while digging the core trench needed to restore the wetland. I am so very impressed with the hard work and the skill it took to build this rock drain. This small diameter hole in the field was the only clue we found showing that rock drains had been installed on the site. The hole formed when the water from the surface washed soil into small gaps between the rocks that were buried in the ground. We uncovered this rock drain while removing and saving topsoil on a wetland restoration project on the Finger Lakes National Forest in New York. The rock drain was still carrying water underground. While restoring a wetland on the Halliburton Farm in Victoria, British Columbia in 2009, we uncovered this rock drain that was still clean and functioning. People attending the wetland workshop recognized the rocks that were used to fill the ditch. They said that someone must have moved these rocks over 1 kilometer uphill from the shore of the ocean to fill the ditch. We intercepted this rock drain while digging a core trench to restore a wetland on the Garry Oaks Preserve near Duncan, British Columbia. The rock placed in the bottom of the ditch was the size of pea gravel and measured exactly 12 by 12 inches. The puddle forming in the bottom of the core trench shows that the rock drain was still functioning to drain the wetland. Drains made of rock or wood can fail if they are installed with wide gaps between adjoining rocks or logs. Another way they can fail is when they are built with only a thin layer of soil covering the rock or wood, and large animals or machines with rubber tires drive over them in the winter or in the spring when the soil is saturated. John Johnston was born and raised in Scotland and moved to New York in 1821. He eventually acquired 320 acres along the shore of Lake Seneca near the community of Geneva in New York. John Johnston built this simple home overlooking the land he purchased to farm. The home is still standing today. John Johnston found that he could only raise about 20 bushels of wheat per acre on the land because the water would stand on the soils that were high in clay. He was basically farming wetland. John Johnston remembered learning about drainage from his grandfather in Scotland and wrote a letter to him asking for help. His grandfather sent 2 clay drain tiles to him from Scotland by boat. John Johnston took these to his friend Whartonby in the nearby town of Waterloo and asked if he would make 3,000 of them for him. Whartonby, a crock maker, was happy for the job, as business had slowed due to the problems associated with adding lead to the glaze he used on whiskey crocks. John Johnston proceeded to dig a series of ditches on the farm and buried the horseshoe-shaped clay tiles in the bottom of the ditches. Some of the ground was so soft that the clay tiles had to be placed on boards so they would not sink. While he was burying the clay tiles in the ground, neighbors stopped by to ridicule him, asking why he was burying crockery in the ground. They said he would go broke, as no one had done this before. John Johnston would stop and explain how water in the ground was under pressure and that it would enter the narrow gaps between the pipes and then flow in the bottom of the ditch downhill. He could farm over the top of the clay drain tiles while they were silently doing their job. He asked them to look at a wet field like a giant flower pot with no hole in the bottom. The clay tiles were creating a way for excess water to leave the ground so his crops would not drown. Elevations had to be taken to know how deep to dig the ditches for placing the clay tiles. Here a survey is being done prior to draining a wetland with clay tiles in New York. The clay tiles really worked. These rare photos show how the installation of clay tiles created a farm field from a wetland. The photos were taken from a book written about drainage that was published by International Harvester in 1929. To everyone's surprise, John Johnston knew what he was doing. His yields changed from only 20 bushels to 60 bushels per acre for the same wet fields. This was big news that spread rapidly throughout the community. Crop yields were greatly increased by adding buried drainage structures made from clay tiles. Here is a cornfield with and without drainage with the same planting dates. The notes say that the corn in the undrained field is short and yellow. Johnston kept adding more drainage structures made from clay tiles to drain wetlands and would show his neighbors how they could do the same. This photo demonstrates how effective clay drainage tiles are at controlling groundwater elevations. I dug this test hole in an old farm field and intercepted a buried drainage system made out of clay tiles. We left the hole open overnight, and when we returned the next day, it was clear that the tiles were actively controlling the elevation of groundwater in the field. People were excited about the clay tiles and figured out more efficient ways of covering the clay tiles with soil. Johnston wrote many articles about how well the clay tiles were working on his farm. Here are a few of the publications in which John Johnston contributed during his life. His friend Mortonby manufactured 3,000 clay tiles in 1838. 10 years later, he was making 180,000 clay tiles per year. The next year, in 1849, he made over 840,000 clay tiles. The demand for manufacturing clay tiles for drainage became so great that by 1871 there were 10 factories manufacturing drain tiles in the town of Waterloo. By 1882, there were over 1,140 factories in the United States manufacturing clay tiles that were being used to drain wetlands. Over the years, John Johnston buried 72 miles of clay tiles on his 320-acre farm. He drew this map to show where the clay tiles were buried. The white dashed lines show where the clay tiles are located. John Johnston died in 1880 after training many how to use clay tiles to change wetland into productive farmland. John Johnston was honored as the farmer who originated tile under drainage in North America. This plaque is mounted near his home. I'm happy to let you know that John Johnston's home was turned into the Mike Weaver Drain Tile Museum. Mike Weaver worked for the Natural Resources Conservation Service and wrote an excellent book about drainage. I encourage you to visit the Mike Weaver Drain Tile Museum. You'll be able to see drain tiles from John Johnston's farm and from all over the world. This photo shows the first field drained by John Johnston with clay tiles in 1838, which is now a vineyard. I returned to the John Johnston's farm and Mike Weaver Drain Tile Museum with individuals who are attending the Northeast Wetland Restoration Institute. The group was able to see the original clay tiles from Scotland that were used by Mortonby to make tens of thousands of drain tiles. Ed Keim, who owns the farm, showed us the fields that had been drained by John Johnston. The drained wetlands didn't look like wetlands anymore. He then showed us an old soil borrow pit he had proposed turning into a wetland to the Natural Resources Conservation Service. The NRCS did not approve of the project because the soil did not have hydric characteristics. Ed Keim volunteered to use his backhoe to help us determine why the borrow pit was not holding water. We dug a deep trench across the drainage downhill of the dry basin. The backhoe uncovered clay drainage tiles about 3 feet below the surface. The clay tiles had been laid on bedrock. The drainage structures that had been installed by John Johnston in 1838 were still working. The clay tiles were responsible for keeping the borrow pit and the surrounding field dry. Since John Johnston's death, there have been many books written about how to drain wetlands using ditches and clay tiles. These books gave practical advice to farmers on how they could change swamps and marshes into agricultural land. Universities developed highly effective techniques for draining wetlands and instructed thousands of agricultural engineers on how they could apply these techniques for creating farmland. The Soil Conservation Service, later renamed the Natural Resources Conservation Service, took the lead in working with farmers to design and pay for the construction of the deep ditches and the installation of buried drainage structures. This drawing from a book published by the Soil Conservation Service in 1973 shows how buried clay tiles will lower the elevation of groundwater in a field. It was of critical importance for a landowner wanting to drain a wetland that there would be an outlet deep enough to carry water away from each drainage structure that was being installed. This outlet must be a ditch that is deep and wide enough to move water off the landowner's farm and over and away from neighboring lands. Here, a tiling machine is starting to dig a ditch and install a buried drainage structure that will drain water from the wetland into this deep outlet ditch. The elevation of the bottom of the ditch to be used as an outlet must be lower than the elevation of any wetlands on the landowner's property that they want to drain. Huge machines like this dredge were brought in by train and assembled on site where they were used to dig the main outlet ditches. Local units of government called drainage districts were formed to coordinate and to finance the construction of these deep outlet ditches. This machine called a dragline is digging an outlet ditch. The design and construction of the long and deep ditches was paid for by taxing landowners who could benefit from the construction of the outlet ditch. Families lived on the drag lines and moved from county to county and state to state to drain wetlands. The deep outlet ditches could drain wetlands over a mile away when the bottom of the ditch intercepted a permeable layer of gravel or sand. The outlet ditches became deeper and wider over time due to the massive headcuts that moved up these artificial streams. Here's Terry Halloran standing next to a deep ditch they call Meadow Creek. Terry's grandfather helped dig this ditch. The soil removed from digging the ditch was used to make a railroad bed. A road was built on the embankment when the railroad tracks were abandoned. This wide and deep ditch was dug to serve as an outlet for drainage structures that were installed in nearby wetlands to create agricultural land. I thought it would be good to show you what a natural stream looks like now that we've seen how the straight and deep outlet streams that were dug for draining wetlands look like. Natural streams are sinuous and bordered by a diversity of wetland types. This outlet ditch was dug along the Illinois River in Illinois. The black box houses a pump that removes water from buried drainage structures located in the fields. I would like to read the caption to this photo published in a 1987 book titled Farm Drainage. This group drainage ditch, formed through dragline construction, replaces an inadequate and obstructed 24-inch tile outlet. The new ditch serves 900 acres on 7 farms near Griffin, Ohio. The green-colored pipe is one of the outlets for a buried drainage system that empties water into the outlet ditch. Here is another outlet for a buried drainage system that is draining water from historic wetlands into a deep constructed outlet ditch. Drain tile outlets can be very hard to find if they are not protected by plastic pipe. This is an outlet for a buried drainage system that is still working even though it's covered with soil. Most clay drainage tiles were installed by hand. The first step was to use a shovel to dig a ditch. The ditch had to be dug on a gradual slope with a smooth bottom. The person digging the ditch in this photo was enrolled in the Civilian Conservation Corps, or CCC program, in the 1930s. It was great importance to use an optical level to design and monitor the installation of clay drainage tiles. These individuals are using an optical level and a grade rod to make sure the ditch is dug on the design slope. This photograph shows brothers Donald and Den Smallwood installing 4-inch diameter clay tiles in a ditch that they had dug by hand in the 1960s to drain a ridgetop wetland to create a tobacco field in Menifee County, Kentucky. A third brother, not shown in the photo, later explained to me that this site originally had standing water. Because they did not have access to an optical level, the ditch grade was controlled using a string stretched between the stakes. These stakes and the guide string were set in advance by the Soil Conservation Service, and they provided the elevations needed to properly install the drainage tiles. This photo illustrates both the determination of the landowners to convert wetlands into farmland and the early use of simple but effective surveying methods to install subsurface drainage systems. These men are using a backhoe to excavate a ditch for installing clay drain tiles. Without access to an optical level, they are relying on a string line stretched across a wooden frame to guide the depth of the excavation. Looking at the position of the worker's hat in the ditch, it appears the clay tiles are being installed at a depth of approximately 5 feet below the ground surface. These individuals are installing 6-inch diameter clay tiles in New York State. They do not appear to be using a level or a string to guide them in digging the ditch. They may be using water flowing in the bottom of the ditch to guide them. The clay tiles will become plugged with soil unless they are installed on a gradual slope. Tractors like the one shown were developed to dig ditches for installing clay tiles. There was still a considerable amount of hand labor to be done to install the clay tiles so they would drain water and not become plugged with soil. Michael Hazlett recently uncovered these 4-inch diameter clay tiles while working to restore a wetland in the Commonwealth of Virginia. 2 styles of clay drain tiles have been used to drain the wetland. One was round with ribs and the other one was octagon-shaped. The drain tiles were buried 3 to 5 feet deep and were still working. Notice how the drain tiles were wrapped with tar paper. This was done as a deliberate filtration measure. The tar paper acts as a primitive geotextile, reduces sediment intrusion while still allowing water to enter. The random pattern of installing buried drainage structures was often used when the landowner was paying for the project. The main large diameter drain line is installed in the center of the valley, with smaller diameter drain lines branching off into individual wetlands. The herringbone pattern of installing buried drainage structures was often used when the Natural Resources Conservation Service designed and was helping to finance the project. The advent of plastic slotted drain pipes and laser-guided digging machines made it possible to more reliably drain wetlands at a reasonable cost. Tiling machines in the 1970s could install long rolls of slotted plastic drain pipe at the correct depth and slope. George McClure in Ohio modified his tiling machine with a rotating disc so it would also cover the drain pipe at the same time plastic slotted drain pipes were being installed. George McClure was able to install the plastic drain pipe accurately while driving through standing water and saturated soils in wetlands. George used the backhoe attachment on the dozer to dig outlets for the buried drainage structures, and the blade on the dozer was used to cover the drain pipes with soil. The laser-guided tiling machines made it possible to drain large areas of wet meadow, ephemeral, and shrub-scrub wetlands at a reasonable cost. This huge pile of slotted plastic drain pipe shows how serious the landowner was in draining wetlands and placing streams underground. This large diameter pipe was used to place streams underground so the wetland would be dry enough to grow crops. This drawing shows how one buried drainage structure can be used to drain multiple wetlands in a large field that is sloped. Can you count how many wetlands would be drained by installing this drainage structure? 6 wetlands and 6 separate wetland basins were drained by one buried drainage structure. I've colored the wetlands blue and the drainage structures red so you can better see them. It's important to understand that if the drainage structure is installed deeper in the ground than the bottom of the wetlands, it does not matter if the surface of the ground is sloped and contains hills and basins. This vertical plastic pipe is called a surface inlet. The surface inlet provides a direct way for water to enter a buried drainage system. Surface inlets are placed in the deepest part of a historic wetland, which is often where water pools in a field after a heavy rain. This shallow water wetland appeared in a field during a heavy rain. The top of the surface inlet pipe is barely visible in the photograph. You can see more of the surface inlet one day after it rained. The pool of water is receding, and we can see more of the pipe 2 days after the rain. The water has gone 3 days since the rain. Drainage systems are designed to remove standing water within 3 days of rain during the growing season, and this is to protect crops from drowning. While enrolled in the wetland drainage course I teach at the University of Louisville, engineering graduate student Austin Robinson photographed personnel from McCain Brothers Excavating installing slotted plastic drain pipe in Gallatin County, Kentucky. Jarrett Malone, the crew supervisor, said that he and his team had previously installed a main drainage pipe and several lateral drainage pipes throughout the fields. The rows of mounded soil show where the plastic drain pipes were buried. Here the crew is using an excavator to expose a section of the main drain line so they may connect a lateral drain line. The person in the ditch is tasked with cutting holes in the main pipe and making the connection. Here's the plastic fitting used to connect the lateral drain pipe with the main drain pipe. This is how the drain pipes are joined together. The tractor is moving this large roll of slotted plastic corrugated drain pipe and will place it on the tiling machine. Here the tiling machine is being positioned and adjusted before installing a 4-inch diameter lateral drain pipe. The plow on the tiling machine digs into the ground and using GPS places the drain pipe at the correct location and depth as it moves away from the location of the main drain pipe. The lateral pipe was installed at a depth of about 2.2 feet below the surface near the edge of the field and about 7 feet below the surface where it tied into the main drain pipe. The tiling machine can place drain pipes very quickly. This photo shows where the main drain pipe was installed. The farmer will return and level the field with the tractor after the soil settles over the pipe. This is the outlet for the drainage system that was installed. The outlet is about 8 feet below the bank of the creek, yet still above the water level in the stream. The early ditches dug by farmers to drain wetlands often eroded into deep gullies. Many of these eroded ditches have since been reshaped into grassy waterways that will not erode. This photo shows a dozer operator shaping a grassy waterway from an eroding ditch near Hardwick, Vermont in the 1950s. The construction of grassy waterways that would not erode required the assistance of engineers. This photo shows 2 engineers with the Soil Conservation Service taking elevations in a grassy waterway being constructed on Ralph Demmer's farm near Richford, Vermont on August 24, 1958. This engineering drawing shows how clay tiles are buried in the bottom of a ditch to form a grassy waterway that will not erode. You're looking at a grassy waterway ditch that was engineered by the Natural Resources Conservation Service to drain a wetland. Simply filling the ditch won't restore the wetland. This is because drainage structures are often buried alongside or beneath these ditches to control erosion and to make the ditch dry enough to cross with a tractor. Many people have told me that simply plowing over buried drainage structures will disable them. What they fail to understand is that these systems were intentionally installed deep enough to avoid damage from moldboard plows, chisel plows, subsoilers, and heavy rubber-tired equipment. Drainage systems have been installed for over 100 years, so agricultural operations will not disrupt them. Some people are convinced that simply plugging the outlet of a drainage system with concrete or mortar will stop it from functioning. This overlooks a fundamental characteristic of these systems. They are installed on a slope and are permeable along their entire length. Blocking the outlet does not stop water from moving through the system. It simply forces it to find another path. The thousands of slots or holes drilled in these pipes along their length makes it impossible to block only by plugging the end of the pipe. Many people believe that crushing clay drainage tiles is a simple and effective way to disable them. This approach does not work. In this video, clay drainage tiles were excavated and run over twice with an excavator, yet they did not break. In addition, the clay tiles were surrounded by gravel, which is permeable. These tiles were designed to withstand heavy loads from farm equipment and are often stronger than people expect. Even if the tiles could be located and crushed, they would still function as a drain. The broken pieces create voids in the soil, allowing water to move freely through them, much like a rock drain. To effectively disable the drainage system, it is necessary to remove or intercept long sections of the tiles and install properly constructed groundwater dams that block their subsurface flow. The second main way wetlands have been converted into agricultural and urban land is by covering them with soil and rock. Many of us talk about wetlands being drained, but very few people know how serious the filling of wetlands has been. This is a wet meadow and a shrub-scrub wetland that is being filled. Here's how the filled wetland appears 5 years later. It doesn't look like a wetland anymore. Wetlands are typically buried under rock and soil that is over 6 feet thick. Wetlands have an irregular surface. Look at the pits, mounds, logs, and root masses in this natural forested wetland. When large trees blow over in a forested wetland, they create a surface of deep pits and mounds. The surface of a wetland is never smooth. This root mass in a forested wetland is 15 feet high. It is very important to recognize that all wetlands are found in basins. A wetland basin can be deep, or a wetland basin can be shallow. The wetland basins can be large, or the wetland basins can be small. All wetland basins are bordered by a rim that acts like a natural dam to keep water in the wetland. People have drained wetlands for thousands of years by digging a ditch through the natural rim of a wetland. Most farmers place a drainage structure in the bottom of the ditch. The drainage structure can be made using rock, wood, clay tile, or plastic slotted pipe. Their next step is to use the soil in the rim to fill the ditch and the wetland basin. The farmer can now plant crops over the covered drainage structure, and water will no longer pool in the basin that was drained. One always uses the soil removed from digging ditches to fill wetland basins. Only installing a plug in a ditch is not restoring a wetland. It is also very important to restore the wetland basin by removing the soil fill. What you see taking place here is a D- job of wetland restoration. This farmer is filling a small wetland basin using a tractor and a blade. These heavy equipment operators are filling large wetland basins and sloping the surface of the ground so it will drain and grow crops. This photo was taken by the NRCS in 1960. Here's an advanced operation where wetland basins are being filled and sloped so a large field can be farmed without wet areas that reduce productivity. It can be very difficult to determine if a wetland has been filled because of the very thick layers of soil and rock that are used to bury the wetland. Some people say that drained and filled wetlands will heal over time. Unfortunately, they are mistaken. Here's a sign of a filled wetland. Notice the steep drop-off along the edge of the fill that was placed in the wetland. Landowners usually begin filling a wetland by placing a small amount of soil near the edge of the wetland or the stream. If no one says anything, they soon add more soil until the wetland is buried. The main thing to remember is that a filled wetland no longer looks like a wetland anymore. This gas station was built on a wetland that was buried under 8 feet of soil and rock. You can still see the chunks of concrete and waste plastic that were in the fill. As with most filled wetlands, there will never be enough funding to restore them. Here's a wetland that's being filled. What signs do you see that a wetland is being buried? The dozer operator is working to fill the wetland basin. There are cattails growing in the ditch, and there's a puddle of water in the background. Can you tell where the wetlands have been drained in this aerial photo? The red dashed lines show where ditches were dug to drain the wetland basins. The yellow arrows point to white-colored areas showing where the ditches have lowered the water level in the wetlands. The blue shaded area shows where wetlands have been drained. This is a very poor quality job of draining because you can still see where the wetlands used to be. This is the type of drainage job you could expect from somebody who did F work at school. Can you find where wetlands have been drained in this LiDAR image? The LiDAR image was taken on the Sumter National Forest in South Carolina. The area is dense forest growing tall pine trees. The wetland basins and the ditches that were dug to drain them are clearly visible. Most of these ditches are less than 2 feet deep. These wetlands were drained to create cotton fields in the 1800s. The deepest part of the drained wetland basin is easy to see in this photo. The blue shaded area shows where the wetland was located. The corn that was planted in the drained wetland basin died because the buried drainage structures that had been installed were too slow to remove water during the growing season. Can you identify signs this area was once wetland? You're looking at what was once a large natural wetland on the floodplain of the Kootenai River near the town of Creston in British Columbia. This wetland, along with hundreds more like it, were drained to create impoundments in the 1980s. The impoundments failed to hold water and the wetlands remained dry. The most obvious sign this area was wetland is the presence of the ditch as shown by the dashed line. You can see where islands were made using the soil removed from digging the ditch. The islands were not used by waterfowl for nesting because the impoundment failed to hold water. Another obvious sign the area is drained wetland is the presence of dense and tall reed canary grass. Reed canary grass can dominate drained wetlands where the basin has not been filled with soil. You can also see the natural rim of the wetland basin that was cut through by the ditch. The shrubs are native hawthorns that have been growing on portions of the rim that were not disturbed by the drainage activity. Can you see where the historic wetland was located before it was drained? A ditch was dug that cut through the wetland rim. The wetland basin was then plowed and shaped into lands so it could be farmed. This entire field was created by draining and filling wetlands. What signs of drainage can you identify from this photo? The deep dug ditch with vertical banks, which is now a straightened stream, is a major sign that wetlands have been drained. The plastic pipe is the outlet for a drainage system that was buried to eliminate standing water and to lower the elevation of groundwater. There is a ditch along the base of the mountain on the other side of the field. The historic wetland basin was filled and the field was shaped so that runoff drains into the ditch. Can you see where the wetland was drained to help make this large farm field? The engine and pump remove water from a buried drainage system and carry the water over the rim of the historic wetland basin. This soybean field on John D. Smith's farm near Sudeth, Kentucky, was created by draining and filling an emergent wetland. This is an A-plus job of converting wetland to farmland. John remembers catching frogs in a wetland where he is standing when he was a boy. The wetland was supplied with water from a small stream and from 2 springs. His father began draining the wetland by moving the stream into a ditch he dug by hand that was bordering his neighbor's property. John recalled when he was a young boy water flowing down the furrow behind him as he plowed the wetland with a pair of mules. John said the soil in the field was blue in color. In the 1950s, John hired a backhoe with an operator to dig deep ditches and placed 5-inch diameter clay tiles in the main ditch and 4-inch diameter clay tiles in the 2 spur ditches to carry water from each spring. Over the years, John plowed soil into the low places with a tractor and used a dozer to fill the wetland basin and level the field. Sometime later, one of the 4-inch diameter buried tile lines from one of the springs became plugged, so he used his dozer to place soil over the spring. John is standing where water from the spring used to emerge. Here John is showing where a 5-inch tile line outlet is in the ditch along the road. This drainage structure is not plugged in over 50 years. I would not have been able to find the outlet on my own. Here is John taking a soil sample where the emergent wetland was located. You can see the soil is not hydric. I once led a field trip to John D. Smith's farm with 13 soil scientists from the NRCS. They also took soil samples in and around the drained and filled wetland. Some of the soil scientists accused John of lying, saying the site was never a wetland. John and I could not understand. It is well known by farmers that if you do a good job draining a wetland, the iron in the soil oxidizes and the soil is no longer gleyed. I have learned that if someone does a good job draining or filling a wetland, the site no longer looks like a wetland. Many wetland creation projects are really wetland restoration projects, only someone has done a thorough job draining the wetland. One must disable historic drainage features to successfully restore a wetland. Here are some important points to consider when designing a wetland project on an area that may have been farmed at one time. Someone has been there before you. Their lives depended on growing crops on the land. They worked tirelessly to remove excess water from the land. These people were every bit as smart as we are today. Attempting to build a wetland without working to identify and reverse historic drainage practices is like trying to cure cancer with a Band-Aid. I urge you to read this book I've written, Wetland Drainage, Restoration, and Repair, to learn more about wetlands and how they were drained and filled across the United States and Canada. I also encourage you to read this book I've written, Wetland Restoration and Construction, a technical guide to learn more about designing and building wetlands. I ask you to memorize the contents of the videos I produced so you'll be successful in building wetlands.
Understanding how wetlands were drained will help you be successful in restoring wetlands. It's hard to believe that this barn behind me was built on a drained and a filled wetland. And that's what we see, is that these wetlands that have been filled and drained are really difficult to spot on the landscape. But there are so many opportunities for restoration. If you like this video, please let me know. And also subscribe so you don't miss any future episodes. And I wish you every success finding buried drainage structures, disabling them, and bringing back our wonderful wetlands.